Okay, so Gauss law. So in Gauss law we'll be studying about electric flux. So our first topic is electric flux. So what is actually electric flux? So actually before starting electric flux আমি electric flux জানার কথা electric flux কোপরা হিসেবে আমি চাম. So it has come from Latin word and it actually means to flow. So flux actually is in layman language a measure of flow. Now this flux actually on what basis it depends. So flux basically depends on different parameters, like as you can see in the drawing. So this green lines, okay, these are actually flux, electric flux. Okay, these are actually imaginary line, we cannot see. Okay, we have just imagine. So this should be the now see the water flowing. Okay, so this can be you can say analogy of flux. Now flux, now on what this flux depends on. So this flux actually depends on three important points. Like first you can see here, so it depends on the area. Okay, so more is the area, more is the number of flux. Okay, these are flux actually flux lines. Okay, these are this red color flux lines. So here you can see in the first drawing this part, here the number of flux lines is 3. Here the number of flux lines is more than 3. So in the second drawing here the flux is more compared to this. So I can say the flux depends on number one is magnitude. Okay, then flux secondly depends on you can see the area. Okay, on what area it is crossing. Here both the areas are same, but magnitude wise second this here more flux compared to the first. Here you can see in the second case area is more, so obviously more number of flux lines passes. So the definition, flux is a measure of the number of electric field lines crossing a given area. Okay, so these are actually imaginary surface, imaginary field lines. Now see the flux depends on area, as I have already mentioned, and also depends on the magnitude. Okay, and another parameter is there, that is the slope. Okay, so slope means on what angle. Okay, you can see here the area, so it is slanting. Okay, in this case the area is vertical, but here with some angle it has tilted. Okay, so flux also depends on this tilting angle. So what I can say, so flux depends on here magnitude, it depends on area, and it depends on angle. Okay, so flux it is denoted by phi, it depends on E, that is intensity of electric field, then area and the angle. Okay, so mathematically I can write phi is equal to this, phi is equal to EA. So this cos term I have introduced. Okay, so vector by vector, vectorically I can write, I can represent phi equal to E dot E vector dot A vector. Okay, so phi, if you break, E dot A is EA cos of some angle. Okay, you can see this is the area. Okay, this is a perpendicular. Okay, this is actually a normal perpendicular to the area, so this is known as area vector. Okay, so A is the area vector and E is the electric field line. So this is the electric field line, so it is the area is with some angle theta. Okay, now what is area vector? You can say, if it is A is a surface. Okay, so perpendicular to this surface is the area vector. Okay, so if this is the area, so this is the vector. Okay, so it depends on the coordinates like x, y, z, x, y, z. Okay, if this is the area, so then this would be the area vector perpendicular to this surface. If this is the area, then perpendicular to this. If this is the area, then perpendicular to this. Okay. So phi equal to EA cos of theta. Okay, now unit. So unit is actually voltmeter or Newton meter square per coulomb. Okay, now this flux is actually a scalar quantity. Alright, it is a scalar quantity. It is not a vector quantity. Okay, so it can be positive, negative, or 0. Okay, it do not have any direction. Okay, so it has got only magnitude. So for a quantity to be vector, it has to have magnitude as well as direction. So here flux do not have a particular direction. Okay, it has only magnitude, so it is a vector scalar quantity. Okay, so now let us solve one simple numerical based on the explanation what I have done. So the question is, find flux of electric field E naught I cap through the area. So okay, this I cap means x axis. Okay, I cap, j cap, and k cap. I cap means x direction. So here the area is given. Okay, so electric field is along I cap, that means along x. Alright, so electric field is along this direction. Okay, this is I cap. So if electric field is this, and you know, so you have to calculate flux. Okay, now see electric field perpendicular. Here you see this is the direction of the area. Okay, area vector. Okay, so flux is what? Phi equal to E dot A. Okay, A is the area vector. So E is E naught I cap into area. What is the area? Area is actually, it is a this is side, this is A side, this is another A side, so A square. Okay, A square into, in which direction? A square, it is in the k cap, so it is z direction. Okay, x, y, z. So here k cap will come. Okay, so area is A naught I cap into k cap into A square. I cap into dot product of I cap into k cap is 0. Okay, or this is one way, or other way you can say E A cos of theta. Here theta is 90 degree, angle between E and A. Okay, E is this direction and A is this direction. Okay, so angle is 90 degree. So this is one way you can say. So cos 90 is 0, or this way you can solve. Okay, there are two ways of solving. So answer is this D. Next problem, not problem, you can say phi is a scalar quantity, positive, negative, and 0. Okay, now see here E. Okay, E is the electric field, E is the area vector. Okay, perpendicular to this area. Alright, so this is the case. I hope you have understood. So this concept only I have used in this numerical. Alright, next is you can see the angle. Okay, so flux depends on angle, as I have already mentioned, magnitude, angle, and the area. Okay, so positive or negative here. So here theta is between 0 to 90 degree. Okay, it is around 45, so it is between 0 to 90, and here the theta is more than 90 degree. Alright, so if it is between 90, so phi would be, so what is the formula? Phi equal to A cos of theta. Okay, theta is between 0 to 90. If it is between 0 to 90, it is positive. Now here A cos more than 90. Okay, so if it is more than 90, then it is negative. Okay, so phi is negative. Obtuse angle. Okay, so it would be obtuse angle because it is between 90 to 180. Alright, now see another problem. Find the flux of electric field E k cap through area shown. Okay, k cap, what is k cap? K cap is actually z direction. Okay, so electric field is along z direction, so in this direction is electric field. Alright, now they are asking the flux. Alright, and so area vector is also in this direction only, area vector. Okay, so phi equal to A cos theta. Theta here is 0 degree. okay, because E and A are in same direction. So A cos of 0 is 1. Okay, now what is the area? Area is A square. Okay, so this is the answer 1. Okay, next, electric flux. So electric flux, this formula I have already mentioned. Unit is voltmeter, Newton meter square per coulomb. Okay, where is the area vector and is the electric field. Next, let us see one question like, in a certain region of surface there exists a uniform electric field. Electric field is given, E is equal to 2 into 10 to the power 3 k cap. Okay, that means along z direction, volt per meter, a rectangular coil of dimension. Some area is given, area is 10 into 20 centimeter square, that is 200 centimeter square, is placed in xy. Okay, so if you draw these coordinates, suppose this, okay, if this is the area, alright, now electric field is along k, that means electric field is along this direction, k cap. Okay, now area is how much? 200. So here 0.2 meter square along k direction. Okay, electric field, and area is also along same direction. It is so phi equal to A cos of 0 degree. Why 0? Because E and A are in same direction. So here how much, what is the electric field? 2 into 10 to the power 3 into 0. Okay, so this is 200 meter square. If I convert into centimeter, then it is, sorry, meter, then it is 0.02 meter square. Okay, here 2000 into 0.02, so it comes up to be 40 volt meter. Okay, so answer is C. So let us move to another problem. I hope this problem is clear. Okay, it's a simple calculation, so I hope you have got this. Next is, if an electric field is given by, okay, electric field is given, so then calculate the electric flux through surface area of 10 units lying in YZ. Okay, so here they are asking the flux. Okay, so the area is in YZ direction. Okay, so Y, Z, X. So this is the area, it is 10 units given. Okay, area equal to 10 units. So electric field, it is in X, Y and Z, but you have to calculate in this. Okay, so if the, here we will be able to calculate the electric field only through X direction. Along Y and Z direction, yeah, we will be able to calculate the electric field only along X direction only. Okay, because along, because here you see perpendicular is, this one is perpendicular. Okay, area, and electric field is along X, Y and Z. So along Z and Y it will be 0 because it is 90 degree. Cos theta will be 90 between between E and A in Y and Z. Okay, so only along X direction theta is 0 degree. So E equal to, sorry, E I equal to E cos 0 EA. Okay, so E is given as 10 I cap to area is 10 is given. Okay, so it is 100 I. Okay, 100 along direction I, so they are asking the magnitude, so it is, answer is 100. Okay, next problem. A square of side A is lying in xy plane such that two of its sides are lying on the axis. If electric field E is equal to, okay, apply the square where alpha is constant, the flux passing through the square. Okay, so this is the question. So here they are asking flux passing through square. Okay, here see area is along xy direction. So here what we'll do, so actually this is variable. Okay, here this is the variable because it is varying alpha x. Okay, and where alpha is a constant. Okay, alpha means actually it should be alpha e naught. Okay, alpha is actually e naught. Okay, here see alpha is actually e naught. So instead of alpha I can write e naught also. So what they are asking the flux through the square. Okay, so here you see the area is given the side of the square, one side is a. Okay, so if you want to calculate this, so you see along k direction the electric field is along k direction. Okay, and the unit vector is also along the k direction. Okay, so this direction is k, this is the k, so area vector and k, electric field and area vector are in same direction. Okay, so E and area vector are in same direction, so angle is 0 degree, but here it is varying. Okay, here you can see alpha x k cap. Okay, so it is varying, so what you have to write, E equal to E naught x k cap. Now see area, how you calculate, you see this integration you have to do. So let us consider this area from here to here, it is x. Okay, it is x direction, so it is varying x dx, and this is y. Okay, so a into dx, this dx. Okay, this is dx area, a into dx area along k cap, area vector is along k. Okay, z direction, so k cap, and E is E naught x k cap. Okay, so k cap, so angle is 0, so phi is equal to E dot dA. Okay, so E naught a x dx, so x dx, so dx is, so you have to differentiate. Okay, d phi, so d phi you have to differentiate from 0 to 5, and what is the limit from 0 to a. Alright, so E naught a x dx, so E naught a is constant, so bring it outside, x dx, so E naught a x square by 2, limit is 0 to a, so put t a here, so what you will get, you will get E naught a cube by 2. Okay, I hope it is clear. So I am just put the limit from 0 to a, so answer is B. Okay, the next problem is, here it is given, like consider an electric field E. Okay, along x direction, E naught is constant, the flux to the shaded area due to electric field. Okay, now the coordinates are given here, so E is E naught I cap, this is a, this is a, this distance is a, and this distance is also a, so yeah, this is the area vector along x-axis, okay, I cap. Okay, now E a cos 0, what is E? E is not only, what is a, area is a square, so answer is a naught a square. Okay, so CI is the answer. Alright, now next problem, we are asking the flux through the shaded area due to this field. Okay, now here it is okay, now the flux will no longer be along particular direction like x or y or z, because it is at some angle. Okay, You have to calculate that angle. Now the sides are A given. If A is the sides given, then what is the area? Area would be these sides you have to calculate. This is A, this is here, you have to draw one perpendicular. Now if you calculate this, you will get here twice of A. If you calculate this, if you apply Pythagoras, you will be getting root 2A by A. Okay, so A would be, and some angle here, angle is 45 degree, you will be getting, so, and this is A. Okay, A into A square. So here the components will come, x component and y component. So here cos of 45 into I cap minus sine component I and k. Okay, along I and k only, along this direction and along like drawing would be so cos 45, if you do the component, if you split the component, you will get cos theta and sin theta. So area would be a square root 2 I cap by cos 45 is 1 by root 2 minus k cap by root 2. So area you got. Now E is E naught. Okay, so flux is E dot I cap E naught I cap only. So I cap and I cap into other cap, like I into I is 1, I into k is 0, I into, yeah, so this part will be 0. So what you will get? You will get a square root 2 I by root 2 minus k cap by root 2. This part will be 0. So you will get only I naught into a square. Okay, this and this will get cancelled. I cap in 1. So this answer is C. Okay, next problem. So next problem is similar to the first problem only. Here only the coordinates are different. Okay, so here area is like here. Okay, in this portion, this is the, so one component if you draw like this is given as 2A, this is 2A, this is A coordinates, this is A, so this is 2A. Okay, and this would be 3a. Okay, so I will not solve this. You try this on your own. The coordinates, and this is also similar to that. Okay, it will take some time and video will be a bit longer, so I'm not solving this. I hope it is clear. Thank you.